Hello all. In this tutorial of engineering graphics, I'll be showing you how to construct a diagonal scale. In my previous video lectures, I have shown you how to construct a plane scale with all different conversions and all. And the next level is a diagonal scale where students will get confused with dividing a line segments into number of parts and all. For that, I'll take a simple problem and I'll explain you how to do. This particular diagonal scale will read up to 3 different dimensions, maybe meters, decimeters, centimeters. 3 different dimensions can be read, means up to 3 decimal points, up to 2 decimal points. For example, let me take 3 units. It can read up to 3 units. For examples, meters, decimeters, centimeters, whereas in case of plane scale, only 2 units are possible to read in that particular scale. Okay, that also I'll try to write. 1 decimal point, up to 1 decimal point is possible, like 1.2, 3.4, something of that kind. Okay. So 2 units in case of plane scale, 3 units in case of diagonal scale. 6.48 can be read in case of diagonal. 6.4 up to 6.4 can be read. Okay. So if I'll say 6.48 meters, then 6.4 decimeters and 0.08 centimeters. Okay. So that can be read by using diagonal scale. So let me take a simple problem just to make you understand how exactly we construct. And in my previous video lectures, I have already shown you how conversions we can remember. Okay. Measure up to distance. Let us take measure up to distance as 6 meters, and for our measure up to distance is equal to 6 meters. Let us consider for this problem, and to calculate the representative fraction, 1 meter represents 2 centimeters on sheet. Every 1 meter represents 2 centimeters on sheet. Alright, let me write that units also. And RF, how to calculate RF, has everything will be normal like whatever the calculations we did for plane scale. So let me write the units also. 1 meter represents 2 centimeters. Now RF can be calculated, 2 centimeter by 1 meter. Now to convert meters also into centimeters, multiplied by 100, simple calculations, which is equivalent to 50. So we can call this as 1:50 RF, representative fraction. Now by using this, we can easily calculate length of the scale. Okay, length of the scale is important to start any of the scale problem. Okay. Now length of the scale is equivalent to RF multiplied by maximum length. Okay. Maximum length given here is 6 meters. Alright, 6 meters. So RF is already calculated, that which is equal to 1/50 multiplied by 6 meters. Now that meters can also be converted according to the measuring scale what we are using, which is centimeter scale. So according to our convenience, we need to convert that meters. Here I kept it as C. Length of scale S, I kept it C. So 6 meters is the maximum length which we have considered for this problem, multiplied by 100. Just I would like to convert everything to centimeters, that is the reason. So if I simplify everything, the whole value will be 12 centimeters. Now these 12 centimeters has to be divided into 6 different parts, because measure up to distance we need to consider, which is 6 meters. Based on that, we will try to divide the complete length into 6 parts. Alright, let me zoom and start drawing the sketch. For that, I'll consider a simple scale just to get a feel of a drafter. Okay, I'm considering this as a scale which is showing 0 degrees. Let me adjust properly. Now we need to measure that 12 centimeters based on whatever the scale I'm using here. So I'll consider that this point as the starting point where the scale will start. For every 3 divisions, I'll make 1 division or 1 part. Likewise, I need to calculate 2 parts, 3 parts, okay, 4, 5, something like this. So I'm trying to divide the whole length of the scale into number of parts. Okay. Now I have considered some 12 centimeters. Every 3 divisions I have considered as 1 centimeter. Just to make you understand, every 3 divisions I have considered as 1 centimeter. Accordingly, now I am considering one vertical line, aligning with 0, drawing a vertical. Here also I am trying to calculate every two parts. You can consider up to 5 centimeters, or else in few cases what actually we'll try to do when we draw diagonal scale is we'll consider one part distance as the height of the scale. One part distance as the height of the scale. Okay, that is also fine. Now I'll just enclose the box to get a feel of scale. I'll just close it like a rectangle. Alright, let me change the angle to 9. As I'm using scale, it will take some time to place it properly, align it properly. So if I draw with a free hand, then maybe we can save some more time, but construction is more important so that you'll understand better, you can perform better in the examination. That is my idea. Now by considering 12 centimeters, I have drawn a horizontal, and a vertical is drawn by considering 5 centimeters as the height. Now we need to divide the length 12 centimeters into 6 different parts. That 6 can be divided simply by saying 12 divided by 6, but the fractions can't be read through the scale, so we can divide by using line division method. Okay, so what I try here is we can simply at every 2 centimeters we can divide it to make it 6 different parts, or else you can draw an acute angle and divide that line into number of segments. That also I'll show you, that line into number of segments, and join the last end point with the corner of the scale. Accordingly draw the parallel lines to get it. Now here what I try here is I'll just try to divide just by going through the divisions. Means every 2 centimeters. This is 1 up to 3. So every 6 parts or every 6 divisions I'll consider as 2 centimeters. Alright, according to the way I have drawn the initial horizontal line. Same thing I'm considering here also. Just to read 2 centimeter dimension. Okay, I'm using some orange color just to make you understand. To divide. Now better to divide this horizontal into number of parts, what I try here is, let me take any acute angle, any angle, maybe 20 degrees, 22, 25, 30 degrees. Okay. I have drawn a line. Now I'll try to divide this line into number of segments. I'll just try to divide this second division, third, fourth. Likewise I'll try to divide this into number of segments, and the last division I'll try to join with the end of the scale and draw parallel lines straight. Now let me rotate and align the end. Okay, 1, 2, 3, 4, 5, 6. Yeah, I made it 7. So that is the reason I'm taking it as considering a 6th division and drawing a line, the end line joining with the corner of the scale. Likewise I'll try to draw parallel lines. Alright, next this is one more. So align your drafter accordingly, tighten the knob and draw parallel lines at each and every division. Now rotate it to 90 degrees. Draw verticals at every intersection. Number 1, this is the second intersection. Alright, third one. This is how you need to draw one after the other slowly, accurately. Okay, there should not be any difference of at least 1 or 2 mm also. So you have to use a pencil which is of very sharp tip so that your drawing will elevate properly. So whatever the construction I am doing from the beginning has to be done with 2H pencil only. Okay, whatever actually required and whatever is need to be shown has to be drawn with HB pencil. Let me decrease the thickness so that I can show you the divisions. This is 0, first division, second, third, 4 and 5. Alright, as I am starting with 0, obviously we are going to get 5 numbers. Alright, if you look at the parts, there are 6 parts. Okay, now here to the right, I'll just specify it as meters. Okay, it is a meter scale overall, and the next lesser unit what I can read is decimeter. Next unit after meters is decimeter, and next unit after meters is decimeter, then comes centimeters. Alright, means we can read all the 3 units by using this particular scale. Okay, how to divide this decimeter scale and centimeter scale, let us see. Now let me take a scale and let me divide the first box, which is a decimeter box. I would like to show decimeter divisions on this particular box number 1 or partition number 1. For that again I'll consider any acute angle and draw a line or drag a line and divide that line into 10 parts, because 1 meter is equal to 10 decimeters. Meter is bigger one, next lesser one is deci, next is centimeter. So 1 meter is equal to 10 decimeters. That I'll just make a note here. 1 meter is equal. Similarly, So we have to divide the first part into 10 divisions, and also the vertical line which I have considered as 5 centimeters also divide into 10 parts. Here that vertical also into 10 parts to read centimeters. Simply I just align the scale with the blue colored line which I have drawn before, and from the point where exactly the one of the division is intersecting with the starting point of the scale, I'll try to divide into number of parts according to my convenience. Okay, according to the convenience you need to divide. That is the reason we use some acute angle. You can consider each division as 5 centimeters, each division as 2 centimeters, 1 centimeter. It all depends on the comfort or the space availability on your drawing sheet. That is the reason we do this practice. Directly we don't divide the part by using a scale or a compass. Any convenient distance with your compass and divide the line into number of parts the way I did. Okay, now simply align the drafter in such a way that the last division should match with, or should be, if you draw a projector line, it should go touch the 0th line or a 0th division or the first partition. Alright, let me align and draw a line. Tighten the knob of the drafter and move the drafter vertical scale to the next division. Draw a line until the horizontal. It will go and touch the horizontal. Next, similarly draw parallel lines the way we did for meter scale. Same thing has to be performed here also. But remember, every line whatever I have constructed till now has to be drawn with 2H pencil only. It should not be dark, it should be light. Alright, so now we are getting number of divisions, 10 divisions, because 1 meter is equal to 10 decimeters. Similarly, we have to divide the vertical line also. So after this we do that practice. Next point, intersection, next point and a line. This is the final one, join. Now simply we need to draw verticals. Alright, we got all the count you could see here. Now again we need to draw the verticals from the intersections. The middle, at the 5th point I am marking it as 5, and finally last one I am marking it as 10, just to make you understand. The reader should understand properly what exactly we meant. Alright, now 3, 4, here you could see number of divisions of meter scale, and here decimeter scale. Now let me consider the scale and keep it 90 vertical. Here what we need to do, as I said, it is a diagonal scale. We need to draw lines at every intersection as a diagonal line. Okay, for that what I do, at the first intersection, 9th term or 9th partition or division or 9th intersection, I'll try to join 9 with the corner of the scale. Have a look, it is maintaining some angle. It is maintaining an angle because the scale is not exactly vertical. Starting at 9th division, it is going to the corner of the scale. Similarly, align it, tighten the knob and draw parallel lines at every intersection. Okay, parallel lines at every intersection. Now this justifies that this is a diagonal scale because we are drawing diagonal lines at each and every intersection. Okay, starting from 9 to 1. We are going in a reverse way. Starting from 9 to 1, I am drawing a diagonal scale at each and every intersection. That is the reason we got a name like diagonal scale. Alright, now next division, next the 4th division. Properly you have to align the drafter. Always try to keep a sharp nib to your pencil so that you will get proper drawing. Again I am repeating, every complete construction has to be done with 2H pencil only. This is the second one, then the last. This is the last division. Alright, let me draw a line starting 1 ending somewhere at the top horizontal. Done. Now decimeter scale is also created. Decimeter scale is done because 1 meter is equal to 10 decimeters. That is the reason first box is divided into 10 parts. First box divided into 10 parts. That is only reason. Now the second conversion is 1 decimeter is equal to 10 centimeter. That 10 centimeters, 10 parts has to be maintained on this vertical also, vertical line which is 5 centimeter line which I have drawn. Here you could see 1 decimeter is equal to 10 centimeters. So I am trying to zoom so that you have a proper visualization. Now let me rotate the scale and I need to divide a line segment. No? So for that I will consider any acute angle and let me draw a line up to infinite distance and divide that into number of parts. Let me draw a simple line of infinite distance. Now I'll try to divide this into number of parts, making markings. 10 markings I need to make because I just want to divide that into 10 different parts. In a similar fashion, what we did for meters and decimeter scale, let me align the last division point and align with the top left corner of the diagonal scale or a rectangle. Then join, tighten the knob of the drafter and draw parallel lines at every division. Draw parallel lines at each and every division, or else you can make marking also of same division on the vertical. As taking the reference, you can make marking like a point. That is also fine, but for your better understanding, I am trying to draw each and every individual line. Once you tighten the knob, it is maintaining an angle of 2 degrees. The drafter is maintaining an angle of 2 degrees. Just have a look. Alright. So that has to be followed throughout the 10 divisions, that 2 degrees. You should not disturb your drafter unless you complete all the 10 different parallel lines at each and every division. That is more important. So once you draw all 10 divisions, from the intersection you need to draw horizontals. Means you need to change that 2 degrees to 0 degrees. After this, simply we made 10 divisions by using grey color line. Now rotate your drafter to 0 and draw horizontals at each and every intersection. Draw horizontals at each and every intersection. Number 1, 2. Draw it accurately, properly, without any disturbance. 1.5 mm is also important. So you have to be careful with whatever the drawing instrument you are using. Always try to maintain sharp tip of whatever the pencil you are using. I am trying to zoom out so that you will have a proper visualization of the sketch. Now one more line parallelly. Next, third one. This is important. That is the reason I am zooming out and showing you. I am taking some enough time actually to make you understand. If I draw a simple sketch with free hand, I may complete a bit faster, but you won't get clarity about how to make divisions and all stuff. Okay. Here only the red lines are maintaining some inclination, diagonality. So that is the reason we are calling it as a diagonal scale. Now I'll show you how to read. Now here meter scale, decimeter, centimeter, all the 3 scales, all the 3 units can be seen. So now what I try here is I just try to give number. Everything is made in English. Then for horizontals, have a look. Here 3, 4. At the 5th division, I just try to make a mark of 5 so that I can read it properly. When you can read the dimensions also simply. Okay, I'll take some other color. 0 to 10 divisions, which is decimeter scale. The bigger one is a meter scale, and 1 meter is equal to 10 decimeters. Those 10 we already made. That marking I made here, and from here I just try to read the centimeter scale, starting at 0 to the bottom left corner, and 1, 2, 3, 4, 5. At 5 I'll just make a mark of 5. Then the remaining, I need to increase one more. Let me count properly and number for our understanding, and evaluator will understand easily, so that if you make marking properly. Okay. So from bottom to top, if you read, you can read the centimeter, 1 centimeter, 2, 3, 4 till 10. Now let us consider how to measure the scale, how to measure 3 units. Let me write it as some. I want to show 3.54 meters. Okay, means 3 meters, 0.5 decimeters and 0.04 centimeters. Similarly 4.62 meters. I would like to show these 2 units on the diagonal scale which we have constructed now, or which I have constructed now. Alright. For that, what I try here is, let me consider the scale again. Let me keep it vertical, because the dimension line will contain 2 extension lines, okay, on either sides. So that I need to mark it properly. Now let me make it to 90 and take it to the scale to the 4th division, where I can read up to 4.62 meters. Let me consider a different color. One of the leg of the dimension line on the dimension line or extension line on 4th division, because I would like to measure a distance of 4.62 meters. This is fine, and to read 0.62 meters, I need to 0.6 is nothing but decimeter scale, so I need to go up to 6 divisions. From there I need to go vertically up on a red line. Try to understand. Vertically up on a red to 0.02 centimeters. Just have a look. I'm just trying to make a mark here on a red line. I'm trying to make a mark of 0.02 centimeters here. This is the point where I can read a dimension of 0.62. Okay, 0.6 decimeters, 0.02 centimeters. Okay, now I'll consider the scale again. I'll just take the scale onto that marking. Simply I'll take the scale onto that marking, and I'll take an extension line up to the top. Extension line, directly a vertical 2H line you need to draw. You are supposed to draw a 2H line up to the top. Okay, then a horizontal. Let me rotate it to 0 degrees. Draw a horizontal where this dimension line can read a dimension or can show a dimension of 4.62 meters simply. Okay, place arrowheads on either sides of the dimension as you all aware of. Okay. Let me show a simple arrow for your understanding. This is how we show the dimension given. So this is what I said in the beginning, like it can read up to 2 decimal points. Okay, 2 decimal points and 3 units, meters, decimeter, centimeter. Again, I'll place one of the leg on third division because I would like to show 3.54 meters, and draw a vertical extension, and point I need to mark, which is 0.54. 0.5 is a decimeter, and 4 on a red line which you could see here. I'll consider some other color. Okay, 0.5 is fine, and fourth intersection of gray color line and red color line will give you 0.54. Now take the scale onto the division and drop or drag vertical extension from here to top, infinite distance. Then make your scale horizontal. Accordingly, draw the horizontal line. Draw a horizontal here to show a distance of 3.54 meters. Close. Let me disable the scale and show an arrowhead here and show the dimension number 3.54 meters. This is how we need to show. Alright, simply. Okay, just to make you understand, I have considered 2 units which will read up to 3 dimensions. Meter scale, decimeter scale, centimeter scale, all the 3 can be read in this particular diagonal scale. So after construction, everything is done. Simply write down the RF value in the middle of the scale, which is 1:50. RF is equal to 1:50, which we have calculated. So here let me place it properly for your visualization. 1:50 followed by, that's it. Okay, RF can be written here. This is a simple construction of a diagonal scale. I hope you understood. If you have any queries, you can drop it in the comment box below. Thank you for watching.